So when we were together last time, we talked about graphing ellipses, and we just did a couple of problems working that. You just really, in this lesson, you need to really be grounded on all the elements of an ellipse. Okay, so the first one is a vertical ellipse. Tell me, what is this point right here at the very top of the ellipse? That is a what? That's a vertex. That means this is a vertex. Okay, what is this right here? Center. What is this? Yeah, and they come in, they match each other. And then what are these 2 points? Yeah, there we go. And then if you do the same thing over here, this is the center. This is a vertex, vertex, co-vertex, co-vertex, focus, and focus. Okay? So know all of the pieces. Now in this one, this vertical axis is called the what axis? This vertical one is called the what? Starts with an M. Yeah. So that means this is the major axis. What is this axis right here? That is the minor. Okay. How does it change over here? What is this one? Yeah, this one is the major. And the one right here, the vertical, that is the minor. Now, by our definition, what is the distance that I draw right here in purple? What is that distance in our formula? What is that? That is A. Okay. And then what is the distance from there to there? What is that? That is B. Okay. What is the distance from here to here? From the center to the focus? What is that? That is C. Okay. Okay. So you just really got to know all of these little pieces. So in this problem here, what is the distance from here to here to the co-vertex? Not A. Vertical is always B. What is the distance from here all the way out? That is A. And then what is the distance from there to there? That is C. Okay? So center to the focus is always C. Center to a vertex, well, if it's horizontal, it's A. Center to a co-vertex, if it's horizontal, it's A. So our horizontal distance from the center to whatever point you have, vertex or co-vertex, is always A. And then the vertical distance from the center to a vertex or co-vertex, doesn't matter what it is, that's always B. So you need to be grounded in that. Now, what we want to do, just like we did with circles, here's the equation of an ellipse, but it's not in what? It's not in the standard form that we memorized for ellipses. We want it to look like this. We want it to look like x minus h squared over a squared plus y minus k squared over b squared equal what? 1. Okay. So what do we have to do to make that happen? What skill did we learn on day 1 of the unit? What is it? This is a what? The 2. That's a square. I need something to be a perfect square. How do I take something that's not a perfect square and make it into a perfect square? It's just completing the square is the skill we'll need for that. So let's move everything to the left side here. So let's just see, we're going to have 2x squared plus 8x plus y squared minus 16y plus 52 equals 0. So what I'm going to have to do, I'm going to have to make that a perfect square and make that a perfect square. Okay. So let's move to the next page. We've got room to do that. So all I did here, I moved that 52 from the left side to the right side. It became a minus. Now, in order to complete the square, what do I have to factor there? Yeah, whatever's in front of the x squared has to be factored. So I'm going to write this as 2 x squared plus what? 4x. And I'm going to leave space. Plus y squared minus 16y. I'm going to leave some space equal negative 52. Now, how do I complete the square? What do I do? Yeah, what is half of that number? Yeah, so I'm going to add 2 squared. Okay. What's half of this number? So I'm going to add 8 squared. Now, here's where people make the mistakes. What is this number? 4. But what did I do to the left side of the equation by adding this 4? What did I really add? I added 2 times 4. Okay. So this is 4. This is 2 times 4. So I added 8. If I add 8 on the left, what do I do on the right? I have to add 8 over here. Okay. This one I don't have that difficulty. This is just adding what? 64. Okay. So whatever I do to the left side of the equation, I have to also do on the right. Now the beauty of completing the square is this gets really simple in a hurry. This is 2 times. What is this? This is what? What is this? X plus what? X plus 2 squared, okay? Because 2 times 2, so the number 2 multiplies to give you 4, adds to give you 4. The number 8 multiplies to give you negative 8, adds to give you 6, multiplies to give you 64, adds to give you negative 16. So plus, what is this? This is what? Y minus 8 squared, right? So it's starting to look more like the equation or the form that I need it, equals, what is 64 minus 52? 12. What's 12 plus 8? 20, okay? Now, this doesn't quite look like what I want it to look like. Why is keeping it from looking like an ellipse? It should be equal to what? 1. How can I make this equal to 1? Divide by 20. Okay. And what is 2 over 20? It's 1 over 10. You can just say 20 divided by 2 is 10. So this is x plus 2 squared over 10 plus y minus 8 squared over 20 equals what? 1. There we are. Where is the center of this ellipse? Negative 2, 8. Is it vertical or horizontal? It's vertical, okay? So let's do another one of those. This is the algebra skill that just needs to be standard. You're going to see this on the quiz with circles. We had these kind of problems with circles, and we have these with ellipses, and we'll pretty much have these until you get out of here. We'll have them with hyperbolas and parabolas. Okay, so completing the square is a big skill. So what do I need to do here? So I need it to look like, I want it to look like x minus h squared over a squared plus y minus k squared over b squared equal 1. So what do I do? Yeah, so let's get all the x's together. So what, 4x squared minus 48x, get the y's together, plus 9y squared plus 72y, and we'll say equal negative 144. Now, what do I have to do to complete the square? In x, I have to be able to factor out what? A 4. So I'm going to write this as 4 x squared minus what? Yeah, 12x, and then I'm going to leave some space right there. Okay. Plus, I need to factor out the 9 y squared plus how many y? 8y, and again, leave some space, equal negative 144. Okay. And now we can complete the square. What do I have to add here? Yeah, so it's half of 12 is 6, so add 6 squared. Okay. What do I add here? Yeah, plus 4 squared. Okay, and this is the one you just want to be really careful. So this is 36 times 4. What's 36 times 4? 144. So this is adding 144 to the left. So I have to add 144 to the right. Okay. And then what did I do here? This is 16. I'm really adding 9 times 16. 9 times 16 is also what? 144. Okay. So however you change the left, you must change the right. So this is 9 times 16. Okay. If you need to put in an extra step to show, you know, what this is this is 4 times 36, which is 144. This is 9 times 16, which is 144. That's why I had to add 144 to both sides of this equation. So, perfect squares now. This is what? 4 times what? X what? Minus 6 squared plus 9 what? Y plus 4 squared equal 144. If this were an equation of ellipse, that would equal what? 1. So how do I make it equal 1? Yeah, divide everything by 144. And so 144 divided by 4 is what? 36. So this is x minus 6 squared over 36 plus 144 divided by 9 is what? 16. So plus y plus 4 squared over 16 equal 1. Okay. Then where's the center of this ellipse? Yeah, 6, negative 4. What is A? A is 6, B is 4. So how long is the major axis? 12. How long is the minor axis? 8. Okay. So just have to be real cautious with the arithmetic and the algebra there when completing the square. Now we're going to shift gears. I thought it was going to be hard last period, but they seem to think it was easy, so you guys should agree, or we'll see. The circle was real easy. What do you have to know the equation of a circle? Center and the radius. Okay, so I could say, give me the equation of the circle centered at blah blah with a radius of 2. That was real easy to come up with the equation. There are more moving parts with ellipse because I could give you the center and the vertex and a covertex. I could give you the center, a focus and a covertex, a focus and a vertex and a center. Several things I can give you. So it gets a little bit more complicated. We're going to run through 3 scenarios here. I give you the center, a vertex, and a covertex. I give you the center, a vertex, and a focus, or the center, covertex, and focus. And you tell me where what the equation is for this. Okay? So I give you a graph here, and you'll see on the quiz, you'll probably see instructions like space to show your work. So what I'm meaning is like this graph is there to help you. If you need this graph to help you figure this out, I'm not grading that. I'm really grading what the equation is. So write the equation for the ellipse that has a center at negative 10, 5, vertex at negative 3, 5, covertex at negative 10, 11. Now, I have to graph this. I can't do this in my head. I have to see this. So let's just graph what we know here. The center is negative 10, 5. So it doesn't have to be perfect. Let's just put somewhere out here is the center at negative 10, 5. Okay. Where's the vertex? Negative 3, 5. So at negative 3, 5 is a vertex. Now immediately, what do you know about this ellipse? It's a horizontal ellipse. And how do you know that? Yeah, if the vertex is on the horizontal line, this is a horizontal ellipse. Okay? And then what's the other piece of information they give me? The covertex is negative 10, 11. So somewhere here, right here is a covertex at negative 10, 11. Okay. So what this ellipse is doing is, it's obviously doing, something like this, But by definition, what is the distance from center to that vertex? That is what? In our formula, what is that? The center to the vertex, the horizontal, what is that? A, okay? Sorry if you said it and I didn't hear it. That's A. And then what is going to be, likewise, what is going to be from the center to the covertex there? That's going to be B, okay? So if I know the center A and B, that's all I need, right? Okay. So in this case, I'm trying to get it to look like this. X minus h squared over a squared plus y minus k squared over b squared equal 1. So where's the center again? Our center is what? Negative 10, 5, okay. And how do we figure out what A is? So what's the distance from negative 10, 5 to negative 3, 5? What's that distance? Am I hearing 7? Yeah, from negative 3 to negative 10, that distance is 7. So A is 7. What is B? B is from negative 10, 5 to negative 10, 11. What's that distance? 6. Okay. B is 6. Okay. If you know these three pieces of information, you know the equation. Okay. So this is what? X what? X plus 10 squared over 49 plus y minus 5 squared over 36 equal 1. Okay. Now you could write it, somebody asked me in the last class, I'm okay if you write it like this. X plus 10 squared, you can write it like this, over 7 squared plus y minus 5 squared over 6 squared equal 1. It's okay to write that. Pardon me? I was going to say, like, square root the whole problem. You can't do that. Okay. No, if you take the square root of everything, you can't do that. I mean, there's no formula for the sum of squares. Okay. Okay, so that was when I gave you the center, the covertex, and the vertex. Okay. Now we're going to switch it up a little bit. I'll give you the center, the vertex, and the focus. Okay. So let's just see what we have. The center is negative 1, 5. So somewhere up here is my center, and that is negative 1, 5. Okay. And then I've got a vertex at negative 16, 5. So somewhere over here is a vertex at negative 16, 5. What do you know about this equation, this ellipse? Horizontal, vertical. This is a horizontal ellipse because the center and the vertex, if they're on the horizontal line, it's a horizontal ellipse. And then the focus. So where would before you even look at the numbers, where would the focus be? Where's the focus going to be? Yeah, it's going to be on the same horizontal line between the center and the vertex, okay? So if you go back to our original, remember when you look at this equation, what we started with, if you've got a center and a vertex, the focus is always in between there, okay? So this one we are on right here. The focus has to be somewhere right here, okay? So I'm trying to get it in the form x minus h squared over a squared plus y minus k squared over b squared equal 1. So I know the center, right? Center is negative 1, 5. Now, by definition, what is the distance from the center to the vertex? I mean, in my formula, center to vertex is going to be what? Well, no. In my formula, which variable is it going to be? A, okay? So how do you get from negative 1,5 to negative 16,5? How far do you have to travel? You have to travel 15 units to get there. So A is equal to what? Yeah, 15. So A is 15, okay? What's the distance from C to F, from the center to the focus? By definition, which variable is that? That is C. From the center to the focus, that's the focal length. That's C. So how do I go from negative 1,5 to negative 1 minus 5 root 5, 5? What's the distance there? You're at negative 1,5, and you're traveling to negative 1 minus 5 root 5. Yeah, 5 root 5 is the distance. So this says you're at negative 1 and you go to the left, 5 root 5. That's the distance that you're traveling. So C is 5 times the square root of 5. What do we not know here? We don't know B, we don't have a covertex, we don't know any of that. But we have an equation that relates these three things. What is that? Yeah, so C squared is equal to the absolute value of A squared minus B squared. I know C and A. What am I going to try to solve this for? I need to solve it for B squared or B. Okay. Can I just take the absolute values away and pretend they're not there? Answer is yes or no. Okay. Absolute value is always what? Positive number. So how do you take the absolute value of 5? It's just what? 5. Okay. How do you take the absolute value of negative 5? So you have to take, if the absolute value of a positive number is always what? That same number, okay? The absolute value of a negative number is the what? The opposite of that. So if I were to know, if I knew that this was positive, I could do what with the absolute values? I could get rid of them, okay? The absolute value of 5 is the same as 5. I could just take the absolute value away. If this were the absolute value of negative 5, I can't just make the absolute value go away. I'd have to take the opposite of negative 5. Do I know if this is positive or negative? Let's go back and look. Yeah, this is a horizontal ellipse, which means what? What does it mean about A and B? A is what? Greater than B, okay? So because this is horizontal, I know that A is greater than B. So when I get down to here, I know that A is greater than B because this is a horizontal ellipse. So that means A squared minus B squared, is that a positive number or a negative number? It's a positive number. So that means I can write this as what? C squared equal A squared minus B squared. So here you have to, you've got to put in a little bit of thought to be able to get rid of those absolute values. You can't just, if you just get rid of them, you got a 50-50 chance of you did the right thing, okay? What would happen, for example, if I had something like this? You know, if I had A, let's just say, for example, A is 6 and B is 7. So if I had C squared is equal to the absolute value of A squared minus B squared. So in this case, A minus B is what kind of number? A negative number, okay? So it would tell me that my answer here would be C squared is equal to the negative of that when I get rid of the absolute value. So it's B squared minus A squared, okay? And so what's the difference here? 36 minus 49, 13. So same thing you would get here. You would get 49 minus 36, okay? So that's where you got to put in a little bit of thought when if you want to get rid of these absolute values. To get rid of the absolute value on a positive number, no big deal, just erase them. Absolute value of 5 is 5. But if I know this is a negative number, absolute value of negative 5 is the negative of negative 5. So if I know this is a negative number, I have to flip this around to be b squared minus a squared. Okay, so that's the part where you got to put in a little bit of thought to make it happen. Now we just go ahead and solve this. We're solving for b squared. So b squared is going to be equal to a squared minus c squared. So b squared equal, what is the square root of 5 squared? Yeah, so I'm going to have, so it's going to be 25 times 5. That's what I get when I square, oh, sorry, let me back up. A squared. What is a squared? A squared is what? What's 15 squared? That's 225 minus, this is what, 25 times 5? So this is 225 minus 125, which is what? 100. If b squared is 100, b is equal to what? Yeah, b is equal to 10. Okay. So I know the center. What was the center of this guy? Yeah. So the center is negative 1, 5. I know a and b. What's the equation here? Yeah, x plus 1 squared over, 225 plus y minus 5 over 100 equal 1. So that is a horizontal ellipse centered at negative 1, 5. And the last example. You are given the center, a covertex, and a focus. Okay? Anytime you're given one of these with a focus, it's going to be similar to what we just did, that you're going to have to solve that c squared equation. So the center is at 2, 8. So somewhere right here, that's my center at 2, 8. Okay. And I have a covertex at 2, 15. So somewhere up here is a covertex at 2, 15. What does that mean about this this ellipse? Not vertical, horizontal. If the covertex is on the vertical line, the vertex has to be on the horizontal line, okay? And then it tells me the focus is where? Yeah. So if this was 2, 8, somewhere 2 plus 4 root 2, 8. That's going to be somewhere over here. There's a focus at 2 plus 4 root 2, 8 is a focus, okay? So that means somewhere over here that I don't know is going to have to be a vertex, okay? So the formula I'm after is x minus h squared over a squared plus y minus k squared over b squared equal 1. So I know the center is what, 2, 8? Now, among the A, B's, and C's, what do I know? Yeah, so what's the distance from the center to the covertex? In my formula, that's going to be which letter? That's B, the horizontal distance. So how far is it from 2, 8 to 2, 15? It's 7, okay? So I know that B is equal to 7. And then what's the other one that I know? I know C, because C is the distance from the center to the focus. What's the distance from 2, 8 to 2 plus 4 root 2, 8? 4 root 2 is the distance there, okay? So I know that C is 4 times root 2. I'm going to have to solve this for what? A. So c squared equal absolute value of a squared minus b squared. I want to get rid of those absolute values. In order to do that, I have to know the positive and negative sign of this. So which is greater, A or B? A has to be greater because I've established this is a horizontal ellipse, which means the A has to be greater than B. So this, inside the parentheses, this is what kind of number? Positive or negative? A squared minus B squared is a positive number or a negative number? It's positive. Okay, since A is greater than B, we know that because it's horizontal ellipse, that means that A squared minus B squared is a positive number. Okay, so the absolute value of a positive number is just that same number. So the absolute values can go away here. So C squared equal A squared minus B squared. What am I solving for? I'm solving for A squared. So A squared is C squared plus B squared. So what is C squared? It's 16 times 2, which is what, 32? What is B squared? 49. When you add 32 and 49, you get 81. So what is C? Excuse me. What is A? A is 9. So with A and B and the center, you're good to go. So what is the equation of this ellipse? Yeah, x minus 2 squared over 81 plus y minus 8 squared over 49 equal 1. Okay. Okay, how does this lesson feel? Okay. 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 There's a little bit of homework in this one tonight. So we've got the block lesson tomorrow, which is your review. So you may have a lot going on. So I'll check the homework tomorrow. If please spend time with us tonight so you can do the review tomorrow. But if you need to finish up the homework in class, that's okay. Excuse me, no. I don't see you till Wednesday. So no excuse. Yeah, have the homework done before you get here on Wednesday. And then when you come in on Wednesday, we'll work the review for the upcoming quiz.